Well, hello there. Today we're going to be talking about wave math problems. Going to use this as a little bit of review heading into our test. It'll be up and coming in the next week or so. Objectives today: we want to be able to calculate several wave math problems, and that's really all I want to get accomplished here. It's going to be service and review. First problem: frequency and period. There is a spring with a 400-gram mass hanging from it. The spring has a K constant of 200 Newton meters. Find the period and frequency. Well, at this point, we've learned that the period is 2 pi times the square root, and we're talking about a spring here, so it's m over the K constant. So T equals 2 pi times the square root of zero point 0.4, because it's 400 grams, not kilograms. We got to put it up here in kilograms. And the K constant is 200 Newton meters. Hold on. The period in this case turns out to be 0.28 seconds. Well, now that we know the period, the frequency is real easy to find because the frequency is just 1 over the period, or frequency equals T inverse. So we simply type that in and hit the inverse button, there it is. And we get a frequency then that's equal to 3.6 hertz. There's a spring with 400, exact same information. Now it asks us to find the wavelength on a 25 degrees Celsius day. Well, I'm going to bring from the previous assignment here the frequency, which was 3.6 hertz. It asked me to find the wavelength on a 25 degrees Celsius day, so I'm going to find, I know that the velocity in air is 331 plus zero point 0.6 times the temperature in degrees Celsius. Well, at this point then, I'm going to take 0.6 times 25 and then add it to 331. The velocity then in air, 25 degrees Celsius air, is 346 meters per second. Find the wavelength. Well, I know that wavelength equals velocity over frequency. Well, the wavelength then turns out to be 346 divided by 3.6. And the wavelength then is 96.1 meters. Hopefully you're pausing these and trying to solve these on your own beforehand. Um, if not, then hopefully you're getting still some bonus or some extra help out of this, nicely bonus. There is one problem that we did with this, and if you guys on your notes can write down what the problem was with this, there's one of the concepts that we used that doesn't exactly work that we went ahead and used anyways. So I'm using it as a little bit of a test. Can you find out what assumption I made that is incorrect for this? Let's go on to wave speed now. Wave speed. Well, I'd invite you to pause this and try doing it on your own. And then when you get done pausing it, I will work through it. All right, hopefully you're back now. Let's see what we did here. A little drum boy is banging on his drum. If he is 400 meters away, how long till the sound gets to you on a 65-degree Fahrenheit day? Couple things we got to do here. All right. Distance equals v or t, or lambda equals velocity times the period. Couple things: I don't know the velocity, but I do know that the velocity in air is 331 plus 0.6 times the temperature in degrees Celsius. I'm going to have to change 65 degrees Fahrenheit into Celsius. Okay, so far I found that 65 degrees Fahrenheit is 18.3 degrees Celsius. I would just simply use your computer for simplicity right now of converting that. Go into temperature, tell it you want to select it first one to Fahrenheit, select the bottom one to Celsius. punch in 65 on the top one and it'll give you that 18.3. So the velocity in air then is 331 plus 0.6 times 18.3. And that gives us a velocity approximately of 342 meters per second. They then give me a distance here of 400 meters. So my lambda, or my distance, is 400 meters away. It's not really lambda, it's my distance here. So to find the time that's going to take to get there, I'm going to say 400 equals 342 times t. T then in this case is going to be whatever 400 divided by 342 is. And we get 1.17 seconds. Well, hopefully that's been a good review of a few common concepts that we've discussed and some math that we have with the physics behind this. If you have any questions, I'll see you on the flip side.